Before we go into the strategy and the process for conducting a hypothesis test, I just simply want to spend a little more time talking about the philosophical mindset behind what we're doing in hypothesis testing, so that you can see some of the strengths of it and you might recognize some of the weaknesses of the process. Now, we assume to start with that we have a population which is interest to us. With most populations, we don't know the mean, and we certainly, if we don't know the mean, we don't know the standard deviation of the population. These are hidden to us. In the number in the population may be very large, and we may have no actual concept of how many there are in the population. Any claim can be made about the population because mu is unknown and the standard deviation is unknown. So a manufacturer who has a product that is the population of interest to us may make any claim whatsoever because the mean is unknown. Our purpose is that we might be able to examine some descriptions of a sample in order to tell whether that claim appears to be true or whether it appears to be false. Now, I point out to you in statistics, you never say it's true. You just fail to reject it. And if it's false, then you reject it and you can claim that. We need a plan to evaluate the likely truth of these claims. So what we're going to do is we're going to take a random sample. Now, I just tricked you with the word random. It is almost impossible to take a purely random sample. That's why when you hear things about politics and you hear things about the pollsters say blah, 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 that they have so much error. It is because they cannot take a truly random sample. They have a convenience sample. They reach to those that are convenience, and convenience samples may not represent the population like a random sample. But if we take a random sample, then with a random sample, we know the number in the sample, we know the mean of the sample, and we know the standard deviation of the sample, and of course we know the variance of the sample. We can then use the random sample, the X bar, N, and S, to predict mu with a confidence level, assuming that S is a good representation or good representative of sigma. Now, these are two things. S as a good predictor of sigma, and the confidence level using the central limit theorem, using X bar with the standard deviation of S over the square root of N to build a confidence level or confidence interval for mu. Now, that's assuming several things. Again, a random sample, presuming that S is a good predictor of sigma, and then we would use the central limit theorem. Now, the confidence intervals can be evaluated. What that means, and the reason we say this is called hypothesis testing, is because if we have a confidence interval for mu based on X bar and the manufacturer's claim is in the interval, then we fail to reject it. If it's outside the interval, then we're going to reject it at a given level of confidence. And of course, we could still be wrong because our confidence of 95%, for example, has 5% error. But that's what we're doing with the philosophy. And I want you to see that again. We take a random sample, we know the number in the sample, we calculate X bar and S. We are in fact going to use a confidence interval. We're going to use it a little differently than when we just did a regular confidence interval. We're going to assume that S is a good predictor of sigma, and then we can make some decision as to whether the concept appears true or not. Now, bear with me. You're headed up the ladder. You have come so far in the last several weeks. I told you that you could do this, and I want you to keep in mind that statistics is not mathematics. Mathematics you may not like, but statistics is a blast, and we're coming to the place very soon where we will be able to use statistical software called SPSS to just roar, and I think you're going to enjoy that. You're making it up the ladder. You've got this.